Hey everyone. Tonight we continue our unit with lateral and surface area of pyramids and cones. So we have talked about lateral and surface area with prisms and cylinders. So now it's all about figuring out what a pyramid and a cone are based on their definitions. So a pyramid is a 3D solid with a polygon as a base and all lateral faces meeting at a single point called the vertex. So again, I have a link here um, to this kind of cool page that gives some extra information about where we see pyramids in real life, the different types of pyramids, and they're named based on the shape of their base. So if the base is a triangle, it's a triangular pyramid, square pyramid, pentagonal pyramid, etc. We're primarily going to be dealing with right pyramids, meaning the height is perpendicular to the base and is in the midpoint of the base, whereas an oblique pyramid is kind of like a slanted pyramid, and the height, I should say, is still perpendicular, although it's no longer centered in the middle of our base. And then, of course, regular pyramids have a regular base, whereas irregular pyramids have irregular polygons for a base. And the area and volume formulas are given to us, of course, on the formula sheet right here. And the one thing that's different is this lowercase letter L, which stands for the slant height. The slant height is the distance from the vertex to the edge of any one of the bases. So the distance that your your butt would take if you were to slide from the top of the pyramid all the way down one of the faces. And the perimeter stands for the perimeter of the base. And of course, the capital B is the area of the base of the prism. So you'll find the area formula for whatever shape your base is for your particular pyramid. So if it's a triangle, you would use the area formula for a triangle. In this case, if it's a square, you would use the area formula for a square, or a rectangle. Those are the most common ones. Okay, for a cone, I think most of us know what a cone looks like. We've probably all been familiar with them since we were kids and getting ice cream cones. By definition, it's a 3D solid with a circular base, a vertex, and a curved lateral surface. So the lateral area, of course, is just the area of the curve. And I didn't mention that up here with pyramids. The lateral area would be the area just of all of your sides. And then the surface area would include the base as well. So you can see that the surface area formula is the same thing as the lateral area formula plus the area of the base, which makes sense. And we see the same thing with the cone. We have the surface area formula being the lateral area formula plus the area of the base, and the base in this case is a circle, so the formula is pi r squared. Okay, and again, we have some interesting information about cones. We can see it in 3 dimensions. See that it has a circular base and that the edges are curved all the way around, and it meets at the top, which we could call a vertex, or they call it an apex on this site. And really what it is it's a two-dimensional triangle that's been rotated 360 degrees. So this is kind of cool. So if we watch this, we see how we create a cone shape by rotating a triangle, a right triangle around. And so if we're ever looking for that slant height, we can use Pythagorean theorem if we're given the height and the radius of our cone to find the slant height. Okay. And make sure that you jot down your 3 questions, and I will see you guys in class.